Let's say we have the functions g of x equals 0, h of x equals 2, I of x equals the square root of 3, j of x equals x, k of x equals 2x, L of x equals 3x plus 1, n of x equals x squared, m of x equals 3x squared plus 1, p of x equals x squared plus 3x plus 5, q of x equals x cubed, r of x equals 2x cubed, and s of x equals 4x cubed plus x squared. Which of these functions are quadratic functions? The functions in this column are quadratic functions. They all have the form f of x equals ax squared plus bx plus c, where a, b, and c are real numbers, with a which is not equal to 0. This form is called the standard form. A quadratic function is a polynomial function whose greatest exponent is 2. Sometimes a quadratic function is called a second-degree equation because it's a polynomial of degree 2. By the way, these functions are constant functions. These are linear functions. Because the greatest exponent of the variable x is 1. And these are cubic functions. Because the greatest exponent of the variable x is 3. Let's look at some graphs of quadratic functions to get a visual understanding of quadratic functions. The graph of any quadratic function is called a parabola. We see that parabolas are shaped like a kind of a U or bowl, or inverted kind of a U or bowl. If the coefficient of x squared is positive, the parabola opens upward. And if the coefficient of x squared is negative, the parabola opens downward. Any parabola shares a kind of symmetry in which a vertical line through the vertex which is an extreme point, divides the parabola in half. Parabolas are symmetric with respect to this line, called the axis of symmetry. If a parabola is folded along its axis of symmetry, the two halves match exactly. If a parabola opens up, the vertex represents the lowest point on the graph, or the minimum value of the quadratic function. If the parabola opens down, the vertex represents the highest point of the graph or the maximum value of the quadratic function. In either case, the vertex is a turning point on the graph. The y-intercept is the point where the parabola crosses the y-axis. And the x-intercept or x-intercepts are the point where the parabola touches or crosses the x-axis respectively. If the x-intercepts exist, they represent the zeros or roots of the quadratic function, which are the values of x at which y equals 0. Let's look at this parabola to check if we understood the vocabulary properly. Determine the vertex, axis of symmetry, zeros, and y-intercept of the parabola. The vertex is the turning point of the graph, which is this point. The axis of symmetry is the vertical line that intersects the parabola at the vertex. The parabola crosses the x-axis here and here. So these 2 points are the zeros of the parabola. And the y-intercept is where the parabola crosses the y-axis. More to come, so stay tuned.